Hello guys, now I will answer you question number 7 from Mechanics 1 Pearson Edexcel A-level exam. Exam was taken in January 2024. In this question, I and J are horizontal unit vectors directed due east and due north respectively, and position vectors are given relative to fixed origin O. At midnight, a ship S is at the point with position vector 19I plus 22J kilometers. The ship travels with constant velocity 12y minus 16j km per hour. Find the speed of S. This is of 2 marks. So velocity is constant, and this is the starting distance it covers. Actually, this is known as starting point. If you remember the formula of the finding the position vector at any instant, it is given as r equals to r naught plus vt. V is the direction vector. It is vt. So this is the formula of position vector at any instant after time t. So this one is the starting point, and it is mostly we represented by r naught. Got it? This is constant velocity throughout the distance. Okay, it covers distance or displacement. It covers. So velocity is the vector quantity. So we can write as 12i minus 16j, and speed is the scalar, and it is equals to the magnitude of the velocity. So you know how to find the magnitude of the vector. This one, we take the square of the coefficient of I plus square of the coefficient of j square, and we get the answer of it. So answer will be 20 kilometers per hour. So this is the speed. First part is done. Now at time t hours after midnight, the position vector of S is s kilometer. Find an expression for S in terms of I, J and T. As I told you earlier, this is the standard formula of finding the position vector after time t. Got it? We have the starting point. We have now V is given, and we can find easily by using this formula. But we have to write the expression as S. S is R, and this is S naught. We can say this one is S naught, starting distance, and Vt. This is also the displacement actually. And V is giving you the direction which way it will move. It will move 12y right side and 16 negative 16 units down. That's it. First of all, let me write the things here. Let me write S naught, the starting point, starting displacement. I'm writing in column vector form. It is much easier to solve. So we can write as 19, 22. It is 19 and 22. And velocity is given there. That is equals to 12 and negative 16. And now we need to find the position vector of S after time t. We can make this formula like this. It will be S naught plus Vt after time t. After time t, this will be the equation. Now substitute the values. 19 and 22 here, plus V is 12 and negative 16 t. So we can write in vector form. It will be 19I plus 22j plus 12y minus 16j into t. So this is the answer for the second part. Second part is done. The next part, a lighthouse stands on small rocky island. The lighthouse is modeled as being at the point with position vector 26I plus 15j kilometers. It is not safe for ships to within 1.3 kilometers of the lighthouse. Find the value of t when S is closest to lighthouse. First of all, actually this one is the direction vector. Okay, this will give you the direction for S, in which direction it is moving now. And Lighthouse is at with this dimension. This is the position vector for Lighthouse. It is 26 and 15. 26 right and 15 units up. No need to draw it accurately, just only I'm drawing the diagram to let you understand and to make it more clear for you. Okay, the concept of this question. The last part. Now let me draw the position vector for the Lighthouse L. So if let's say this is the origin O, and position vector for L is 26i 15j. 26i means 26 units right, and 15j 15 units up. So it will be somewhere here. Okay, so we can, this is L, so we can join over here. So this will be the position vector for point L, Lighthouse. So better write the column vector for this one. It is 26i and 15j. So this is the position vector for L. And S is, for S, you know, it is the displacement after time t. The displacement direction is given by the velocity, by this one. Got it? This is called the direction vector for the position vector for S. So this is the direction in which it is going on. So it will be 12 units right and 16 units down. It will be somewhere here. I'm not drawing actually. I'm just only sketching it. Okay, I'm not drawing according to the scale. Let's say S is here. This point S is here. Okay, and we can write the position vector for this one as, it will be here. We can join it. Great. So this is the position vector for S, and we already got the position vector. That is 19, 22 plus 12 and negative 16 t. So this is the position vector for S. Find the value of t when S is closest to the Lighthouse. It will be closest if there is a perpendicular distance from here to here, right? If it is perpendicular to this point. So L and S will be closest if we can say this LS, this line segment, LS is perpendicular to this vector. Got it? LS is perpendicular to this position vector. So direction of this position vector is given by the velocity. So here, this is LS. LS or SL, it is up to you. So here I am writing as LS. We can find the position vector for LS. LS is equals to OS minus OL. So OS minus OL, because OL plus LS is equals to OS. So LS will be equals to OS minus OL. So OS is, better you combine them. I is 19 plus 12t I. So we can write as 19 plus 12t. And here 22 minus 16t minus OL, that is 26 and 15. Now solving, 19 minus 26 is negative 7. So it will be 12t minus 7. And from here, 22 minus 15 is 7. It will be 7 minus 16t. So this is the vector LS. We can write over here, ship is closest to Lighthouse if LS is perpendicular to the direction vector, that is V for sure. Because here this is V, V is the direction vector. Got it? This is always direction vector. It gives you the direction. This one gives you the direction. I already explained to you here, over here. This is called the direction vector. This gives you the final direction for R. Okay. So we have to consider this vector to determine the direction for the final position vector for the ship here. Okay. So if LS is perpendicular to V, we know that LS vector, the dot product is always equals to 0 for perpendicular vectors. The dot product of perpendicular vectors is equals to 0. and ls we already got it, that is 12t minus 7, 12t minus 7, and the other one 7 minus 16t, and here dot with the direction vector, that is 12 and negative 16 equals to 0. We know in dot products we multiply I with I and j with j. 12 multiplied 12 is 144, t minus 84, then 7 will multiply by minus 16, it gives you minus 112, and minus and minus makes plus 256 t. 16 multiplied 16 is 256 t equals to 0. 144 plus 256 give you 400 t, and this minus 84 and minus 112, negative 84 minus 112 give you minus 196, and we will take it on the right side, it becomes positive, so it will be 196. T will be equals to, you divide by 400, and we get the answer as 0.49 seconds. So it will be it will take 0.49 seconds when it is very close to the lighthouse. It will be closest at the point when this vector becomes perpendicular to that vector. Okay, so at this instant the time taken is 0.49, and what is the distance here? We can plug in over here to find the vector value of t, and then we will find the magnitude. And safest, this is the first part actually, hence determine whether it is safe for S to continue its course. Like if the answer is more than 1.3 kilometers, it is then it is safest. If it is less than this distance, ls is if we find the distance, this one L and S, if that distance is less than 1.3, then it is not safe. Okay, first of all find ls, plug in the value of t over here, we will get the vector ls. ls vector is equals to let me write the vector here, 12t minus 7, 12t minus 7, and here 7 minus 16t. Now plug in the values, it will be 12 into 0.49 minus 7, and 7 minus 16 into 0.49, and here get the answer. So this answer is minus 1.12. Answer of this one is minus 0.84. Now find the magnitude of this this displacement. We know the formula for finding the magnitude of this one, that is the coefficient of I square plus the coefficient of j square. Okay, and we take the square root. Get your answer? Answer of this one is 1.4 kilometers. You know, this distance is greater than this distance 1.3 kilometer, therefore it is safe. Okay, is greater than 1.3 kilometers, therefore it is safe for S to continue its course. Okay, so this is the final part of this question, and question number 7 is done. If you have any question, any doubt, please ask me in the comment box. Thank you.